Hello friends, welcome to CS Tunes. Continuing the video series on pumping lemma, today we will discuss the pumping lemma for context-free languages. In our previous video, we have used pumping lemma to prove that a given language is not regular. In this video, we are going to learn that how we can use pumping lemma to prove that a language is not context-free. The statement for pumping lemma states that for a context-free language A, suppose you are given a language A that is context-free, there must exist a constant P. P over here is our pumping length, such that the every string S in our language A has a length greater than equal to the pumping length. That means the length of every string in our language should be greater than equal to the pumping length. If this particular condition is satisfied, then we can break our string S into 5 substrings. These 5 substrings can be represented as U, V, X, Y and Z. And these substrings must follow the 3 conditions provided over here. According to condition number 1, the length of substring V, Y taken together should be greater than equal to 0. Condition 2 states that the length of substrings V, X and Y taken together should be less than equal to pumping length P. According to condition 3, U V to the power I, X, Y to the power I, Z should be in our language A for every I greater than equal to 0. That means if we are going to arrange the substrings in this order such that V is repeated I times and Y is repeated I times, and it must follow the order U V to the power I, X, Y to the power I, Z, then this particular string should be in our language A for every value of I that is greater than equal to 0. To understand pumping lemma in more details, refer to our previous video. Link for the same has been provided in the description section below. Now let's discuss the steps to prove a language is not context-free using pumping lemma. So according to step 1, let us assume that the given language A is context-free. Then find the pumping length P. After this, find a string S in the language A such that the length of the string S should be greater than equal to the pumping length P. After this, we have to divide the string into 5 parts, that is U, V, X, Y and Z. While dividing the string S into 5 parts, you should try to divide it in all the possible ways in which you can divide. That means consider all the possible ways in which you can divide S into U, V, X, Y and Z. Now show that U, V to the power I, X, Y to the power I, Z doesn't belong to A for some I. Now you have to prove that the string which is formed using U, V to the power I, X, Y to the power I, Z is not the part of your language. If it is not the part of your language, that means your assumption that A is a context-free language will not be satisfied. Now, according to step 6, take a value for I to be used for U, V to the power I, X, Y to the power I, Z. Then show that the 3 conditions of pumping lemma are not satisfied for all the possible combinations of U, X, U, V, X, Y and Z at the same time. If any of the 3 conditions of the pumping lemma is not satisfied, that means the string which is provided to us is not satisfying the condition of the pumping lemma. It means that this is not a context-free language. So, In other words, we can say that S cannot be pumped. Hence, our assumption that A is a context-free language is wrong. So, we have proved that A is not a context-free language. Now, let us see an example so that you get a clear idea that how you are going to apply pumping lemma to prove that a particular language which is given to you is not context-free. Suppose an example is given in which you need to show that the language A, that is A to the power n, B to the power n, C to the power n for all n greater than equal to 0 is not context-free. So over here you are given a language in which number of A's is equal to number of B's is equal to number of C. But A is followed by B and B is followed by C. That means all the A's will be in the beginning, all the B's will be in the middle and all the C's will be at the end. But the only thing is that since the power is equal for the three variables, so that means number of A's should be equal to number of B's should be equal to number of C. For this particular language, you need to prove that it is not context free. Now let's start with our proof. So the step 1, assume that the language which is given to you is context free. Step 2, find out the pumping length. So we have taken our pumping length as 4. You can take any value of your pumping length whichever you want. In this video, we are taking it as 4. You can take it 5, 6, 7, whatever you like. Now you need to find a string S such that it should be greater than equal to our pumping length. Now we are finding the string S. So we are saying that A to the power P, B to the power P, C to the power P. That means A to the power 4, B to the power 4, C to the power 4. You can take any string whichever you like. But in this particular case, we are taking it as A to the power P, B to the power P, C to the power P in order to be confirmed that the length of the string S is always greater than the pumping length P. So this string can be written like this also. 4 times A followed by 4 B's followed by 4 C's. Now let us consider two cases and take the values for u, v, x, y and z. You can take n number of cases. In this video, we are taking only two cases. So it is not mandatory that you have to take the same values. You can take any value, whatever you like. You just need to prove that this particular language is not context free. So according to case 1, we are taking the value of u as a, v is taken as double a, x is taken as a 4 times b, c, y is taken as c and z is taken as double c. In case 2, we have considered u as double a, v as double a double b, x is equal to b, y is equal to b and z is equal to 4c. You can take other cases also. Now, according to step 5, let us assume any value for I. For I also you can take any value. We are assuming I to be 2. So we are taking the value of I is equal to 2. Now we are going to check the three conditions of the pumping lemma which we have discussed over here. These three conditions are satisfied or not. If these three conditions are not satisfied, that means our language is not a context-free language. So for case number 1, when the value of I is taken as 2, that means if u is a, so we have taken single a, then we are having v as double a. So I value is 2, that means 4 a's will be there. Then x is taken as a, b, 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 c. So it will be copied as it is. Then y to the power I, c. That means c is taken as 2 times because the value of I is 2. And then z is taken as double c. Now we will check the three conditions. Condition 1 states that the length of the string vy taken together should be greater than 0. So v is equal to double a, that means its length is 2 and y is equal to single c, that means its length is 1. So 2 plus 1 is equal to 3. The length of substrings vy taken together is 3, that is greater than 0. So condition 1 is satisfied. Now let's check for condition 2. In condition 2, we are taking v, x and y together. So the length of v is 2, double A. Length of x is 1, 2, 3, 4, 5, 6. The length of x over here is 6. And the length of y is 1. So it totals to 2 plus 6 plus 1, 9. That means the length of v, x and y taken together is 9. That is greater than our pumping length, which we have assumed as 4. So the condition is not satisfied, because according to the condition it must be less than equal to our pumping length. Now let us check the condition number 3. According to condition 3, u v to the power I x y to the power I z should be in our language A for every I greater than equal to 0. So for I equal to 2, if we check, we find that number of A in this particular string is 6. Then number of B in the string is 4. And number of C in this particular string is 5. So we find that number of A is not equal to number of B is not equal to number of C. So the string according to this particular case 1 is not a part of our language. So condition 3 is not satisfied. Now let's take the second case. In the second case, we have assumed U as double A, V as double A double B, X is B, Y B and Z as 4C. Now for condition 1, if we check the length of V and Y taken together, so length of V and Y taken together is 5 and 5 is greater than 0, that means condition is satisfied. The second condition is VXY, length of VXY 4 plus 1 plus 1. That means 6. 6 is greater than P because P was assumed to be 4 and it should be less than or equal to P. That's why our condition number 2 is not satisfied for this particular case also. Now for condition 3, we are going to put the value of V I times and Y I times. That means V to the power 2 and Y to the power 2 because we have assumed I to be 2. So what we are doing, AABB is repeated 2 times. So in our string AA, then AABB, again repeat AABB because V is taken 2 times, then B, then single B is repeated 2 times because Y is also taken as Y to the power I. So over here if we find the number of A is equal to 6, number of B is equal to 7 and number C is equal to 4. So number of A is not equal to number of B is not equal to number of C. Also, the order in this string is not followed according to our language, that all the A's should be followed by all the B's should be followed by all the C's. So, the string according to case 2 is not a part of our language. That's why condition 3 is not satisfied. That means S cannot be pumped. Hence, our assumption that A is a context-free language is wrong. Hence, the given language is not context-free. So, following the steps provided in this video, you can prove that a given language is not context-free. Thank you for watching our video. For further queries, comment in the comment section below. Stay tuned for more videos and do like and subscribe our channel CS Tuts. Thank you.